Hello community! Yes, today is about agents and we compare agents in GPT-4 with Code Interpreter to the new AWS Amazon Bedrock Agents. What is the difference? What is their performance? Now, you know that in the last video I showed you here I have some central intelligence AI within GPT-4, and I ask here the central intelligence to create 3 different agents. First agent is here a data cleaner. Yeah, maybe let's improve here the settings. Data cleaner functionality, competence, and the tools you can use. And then we have here the second agent and the third agent, functionality, competences, and everything you find here the summary in this video. But now, in the middle of August 2023, we have now Amazon Bedrock. In Amazon Bedrock, you will have LLMs, like the one by A21, Titan by Amazon, Claude by Anthropic, Stable Diffusion by Stability AI. So you will have here with Amazon Bedrock a lot of large language model that you can choose from. That is great. However, what is nice that Amazon Bedrock provides you here the ability, just show us here some S3, and you can fine-tune your foundation model for particular downstream tasks in the easiest way, and Amazon makes a separate copy of the base LLM, of the base foundation model that is accessible only to you and trains this private copy of the LLM. So all of this is behind the proven Amazon firewalls. So since some user ask, make it clear when there's something new, so you can fine-tune your private LLM copy with Amazon Bedrock. By the way, not sponsored. Great. Second, we have agents that we can apply for Amazon Bedrock. Because imagine you want to make an API call to your company systems, to your company database, to your company inventory, to your company document server. So we can connect, and Amazon provides here agents for you. First, you need to give the agent access to your corporate data sources and connect it with existing APIs. Second, the LLM needs to figure out what actions to take for a particular job that you want the LLM and the agent to do. So the LLM has to configure the agent in a particular way. So this includes building prompts that include here the definitions, what to do, how to perform the task, and instruction for this task. You know this. So what they do, the agents automate the prompt engineering and the orchestration of the user requested task. So the agent will automatically build the prompt and augment it with your company specific information that it got back from the API call to your business database that you have here. And all of this within the secure environment of AWS. You can break down the task in multiple steps, a sequence of API calls. You can go to multiple of your databases or whatever information sources you have. And the nice thing, a fully managed agent, you don't have to worry about provisioning it or managing at all the cloud infrastructure. This is done because you pay Amazon exactly for this. And the nice thing, it performs all the API calls using the proven AWS Lambda functions. So, for my viewers here, the second interesting point, the agents automate the prompt engineering plus the API calls to your business database. Nice thing is, we can help here our LLMs to reason, to have some advanced reasoning. We want that the LLM reasons not on what it has been pre-trained or on what we fine-tuned it, but we say, hey, for this particular task, I want to show you how you have to tackle these problems. Step 1, 2, 3, 4. Follow this. We know this. This is our old friend called REACT, reasoning and acting. You can structure prompts to show here our foundation model, our LLM, how to reason here a particular downstream task and decide on all the action that will help the LLM to find a solution. Structure prompts include a sequence of question, sort, action, observation, example. So point number 3, we can not only fine-tune our LLM, but we can optimize our LLM for a particular task that the agent should do that our LLM will help define. And we can use here advanced reasoning with React. Ben, this is for you. React, what is React? Here we have the publication. Google and Princeton here. React, synergizing reasoning and acting in language model. And if you want here the example, on the left side we have a chain of sort argumentation, and on the right side we have React. So we have here with chain of sort, normally a sort, an answer. Question, sort, answer, question, sort, answer, question, sort, answer, you get it. With React, we have a different sequence. We have a question, great. Then we have a sort 1, an action 1, and observation 1. Then sort 2, action 2, observation 2. Then sort 3, action 3, observation 3. You got it. And then here we have a lot of examples. This is one example to come to the right conclusion. Advanced reasoning with React. Is it the best and optimal system? No, but it is great with LLM. So here we are. Since Amazon Bedrock Agents are not operational and they are currently in an interim by invite only, and I decided today during breakfast to do this video, and in the last 4 videos, in the last 4 hours, Amazon did not come back to my request that I get access here to this preview version. Sorry, Amazon, you missed an opportunity. So let's see here what they tell us, what it should be able to do once it will be released to the public. For example, in the agent, you have a shopping agent. Either it is predefined by Amazon or you can define it, whatever. You have an agent. As I showed you in my video, it is rather simple. You prepare it, you deploy it, and the description of the agent is enables human-like chat interaction about shopping experience. And you say, wow, and here you have here what Amazon gives us in the manual. So system comes up, how can I help you? You say, hey, I'm looking for some shoes. Amazing, at Amazon you're looking for shoes. System says, sure, can you tell me what size, or man or woman, any style preferences? So what you normally would have if you're at Amazon.com, you would have to type in. Now we have a conversation, isn't that beautiful? And then the system knows exactly what's in the inventory and says, hey, I suggest here this for this particular price. They're on sale right now. They're good for the purpose you are looking for. So isn't this great? And you say immediately, hey, I know you have this video here about the integration here of Salesforce, their Einstein GPT system, how they use it exactly for sales and services and. Yes, of course, they have the sales GPT, the service GPT, and. So this is not unique to Amazon. This is what is coming to more or less every company. It just depends on which platform you as a business owner you want to run this. So what are the problems I showed you in my last video? I was showing you how to build agents in GPT-4 with Code Interpreter. One problem was if I have a huge amount of data, more than 5,000 real projects with project description, technical reports, financial data, time schedule, and. At a certain time, if I wanted to perform some topological dimensionality reduction on the complexity of the project thematic topics, I ran into out-of-system RAM error. So it is not that GPT-4 fails. It is not that the code interpreter fails. It generates the code. But the code execution, there's only, I don't know what, limited amount of Python environment code execution engine with a certain amount of RAM. And if you really have thousands and thousands of projects and you run a complex mathematical operation, you will get an out-of-system RAM. And I was not able to cope with the system RAM because Code Interpreter is for me a black box with GPT-4. I can't optimize the parameter of Code Interpreter. This would be great, OpenAI. OpenAI, if you're listening here, this is something for you to optimize. Yes, and I'm going to pay for this too. Now, here on AWS Bedrock, we have no problem because we have our Lambda functionality with AWS. So I just tell them, hey, here is my second credit card. And it says, hey, great, we switch on another cloud machine for you. Isn't this fascinating? But what's really interesting is you can build, in addition, your own specific agent. So here, important point number 4, we have the agent action group here to your business databases or whatever information sources you have behind your firewalls. So we can build our own agent. Isn't this great? So overview, this is just from the manual, since everything is just an internal by invitation only preview. So yes, you know. Great, so let's do this. Step 1, provide agent details. The agent name is insurance claim agents, okay. Agent description, user input, yes and no alert. And I have here my security, great. And then I can choose here a model from the models that Bedrock provides to me. Let's say I go with Anthropic CLAUDE version 1 or CLAUDE version 2 or whatever. I define here the instructions for the agent. You are an agent designed to help with processing insurance claims and managing pending paperwork. Up to 800 characters you can insert here with Bedrock, and you say go. And here, this is the interesting part. It is optional. It is really optional because, as I showed you in my video, the LLM will define an agent for you, and GPT-4 defined here exactly with Code Interpreter as a tool agent, if you want, or as an autonomous agent, here exactly what I needed to do what mathematical operation for exploratory data analysis. Have a look at the video if you want to know more. But here now I can define here what I want. I have a description, and then you have two things. You have your Lambda function that you have to define, that you have to code if you want. And you have, of course, here provide here the OpenAPI structure in a JSON file, I would suppose. So here you have now access to your internal databases, if you're a business or whatever. And we can define here exactly the action that is going to happen. And this is, for example, something I cannot do out of the box with Code Interpreter with GPT-4. Maybe I would need some other additional LLM that act as an agent, for example, Gorilla, but this is part already of another video I showed you. So what do? We say, okay, we created the agent. I will show you in a second how we do this. You select the model, you have the action group, and you have defined your Lambda function. This is here. And you have defined your JSON file with the OpenAPI commands. And then you say, create agent. That's it. Now, isn't this interesting? Simple example. What we have here our Lambda function and Lambda handler. We got here a specific function, get the claims. We're an insurance company. And here we have now exactly the function, and we have here the claim identification number, blah, blah, blah. And we have the identification of the policy holder, and maybe you have the name and the address and whatever. And there's a specific status to this process or to this document or whatever you have. And this is it. This is the easiest example I could think of. If you want to make it a little bit more complicated, well, we have exactly the same. You have your Lambda handler. You define here your function, get claim documents, get required documents, check out if there are some missing documents that are not in the required document in the claim document, compare it, tell me what's missing, blah, blah, blah. And then simply you define here your functions. Document ID, whatever. You get the idea. It is rather simple. So with this third action group, this is really interesting. And I think this is really outstanding that you can build this in the connectivity to your secret, private, protected business databases. So the action group, the JSON file, specifies the action group that you want to add to your AWS agent. Each action group in the file has the properties of 1, 2, 3, 4. The Lambda function is responsible for processing the API call. Of course, that is associated with this particular action group that you defined here. The Lambda function itself must follow the properties A, B, C. The Lambda function, for example, the getClaims action group that I just showed you, retrieves the claim from the database or any other data store, document store, data lake, delta lake, whatever you have, and returns them in a JSON response. So you can augment now your query with this particular information for the LLM and the associated agent to perform its task. This was it. I think very interesting what will come up here if Amazon will switch this operational for everybody, especially the ability to build here. Let's call it LLM-induced or LLM-augmented Autonomous Agents, LAA. And if you want to build your own agent to have a connection to your own business data, you do not need to go with some long chains, but you have everything here behind the closed door of cybersecurity provided by AWS for you, for your data, for your business data. And I think this is an interesting business application. So this is the first video. I will make maybe another video where I also have here a comparison then with Hugging Face agents. And Hugging Face has some really nice feature coming up. So I would like to show you how then the agents in GPT-4, in AWS, maybe in Hugging Face, maybe also include some Google. Let's see what comes up. But you see autonomous agents that are controlled and defined by the intelligence of our large language model or our visual language model or visual language action robotics models. This is a topic that will, I think, in the future be of central importance for business application that you can run in any cloud. It does not really depend here on the LLM that you choose, Anthropic, OpenAI, Google, or Amazon TITAN. I don't know what is Amazon TITAN. If somebody has some benchmark on the logical reasoning capabilities of Amazon Bedrock TITAN, please leave a link in the description. Otherwise, I hope it was a little bit informative, and it would be great to see you in my next videos.